Hello and welcome. My name is Ulf Berglund and I will be the one that will be guiding you through this webinar for MagiCAD. We will be looking at MagiCAD 2016.4 Sprinkler Designer on Revit. I will start off by going through a PowerPoint, just a short PowerPoint, and then after that we will go into Revit and I will try to show some features we have. Since this is an introduction to MagiCAD for Revit, I will go through some base functions that we have, also not only new functions in this newest release that we have. So let's start with the PowerPoint. Just move some stuff around here. So the agenda for today. I will start off by, in Revit, showing some of the MagiCAD ribbons that we have, a general overview, just to look at some productivity tools that we have and some, well, the base layout of the program software. And then after that, we will look at creating a network. We'll both select and install sprinklers to the project. I will show you the product browser that we have. It's a function where we can select a sprinkler head or valves or pumps or what we want to place in the project. So we can search through the databases that we have in MagiCAD. There are quite a lot of different products. Then we will look at how to draw pipes with MagiCAD functionality. We will look at the connection tool that we have to connect sprinklers to pipes. We will look at how to place, for instance, a valve into the system. We have a simpler sizing function. The sizing function is so that you say that you want a certain diameter of the pipe when we have a certain amount of sprinkler heads attached to it. The calculations, we will go through them and make a calculation and see the calculation report, and we will add some node numbers also into the project. Then we'll go into the productivity tools, and we have this crossing function, and new for this version is the multi-crossing. This is when we have pipes that are colliding with other pipes, or it could be with cable trays or ducts or something else that we have linked in. Then we can use the crossing tool to make our way past that object in an easy way. Angled horizontal, it's a way of drawing pipes with an angle. Normally in Revit, if you want to draw a pipe and you want to make a height change, and say you want to do that height change in a 45-degree angle, then you need to go into a section view to draw that. But with our angled horizontal, we can do this from the floor plan. So from top view, we can draw with an angle. Standard connection, it's a tool where we have two different pipes on different heights and we can connect them. We can also connect directly to a bend, and MagiCAD will automatically create a T-branch instead, for instance. Common MagiCAD functionalities. Void provision, we have a tool for creating cutouts. So what we can do with this tool is that we can say that we want to make a request for a cutout, and then we can send this to the architect or to the construction people. And we also have an add-in to Revit, a void tool that's free. And the structural engineers can use that tool to create the actual cutouts. And then when we get it back in the new model, we can make our interference check and see that we have no more collisions. Create symbol, it's a way of creating 2D symbols that we want to have for the sprinkler heads, for instance. So I will go through now in Revit and draw, and after I've done with the points that we have in this agenda. So let's see if we have time for questions. In that case, you will be able to write them into this tool. In case we don't have the time to do it, you can always email me at ulf.berglund@cadcom.se or to Progman. But I will see to that they get the questions that you have. If you write them in the tool, then we will automatically see. If we write it in the GoToWebinar tool as a question, we can see it in the report also. So then we get your email address and so on. So let's go into Revit. If we then start off by talking about the MagiCAD ribbons, as you can see up here, we have a few tabs. There is actually one more tab that I have turned down. It's some called support and hangers. But for me, I didn't need it for now, so I just took it away for this feature. But we also have a tab that's common for all disciplines, and then we have a tab that is specific for ventilation, one that is specific for piping, and here we can find our sprinkler tools. And then we have one for MagiCAD electrical. If you don't want to have these tabs visible, you can always go into the settings of MagiCAD, and you can here say that in appearance that I don't want to show them. The support and hangers, I have turned it off in a different way, so that's why it's still checked here. But so first button, dataset. I don't know how many of you that are familiar with MagiCAD on AutoCAD, but we have a slight difference between how we use the products in MagiCAD for Revit and AutoCAD. You can think of the dataset as a container. This container, it's a file where we can select all products that we think that we want to be work with. And then when we actually take one product from this dataset, from this container, and place it into the Revit model, then the Revit family will be created, and it will start to weight down the drawing with that amount of megabytes that family is in size. So actually we can have a lot of products that are close to it's easy for us to use it when we want to draw with them, but still they will not affect the project's size before we have placed it in the project. So this dataset, think of it as a container for products that we might want to be used in the project. The provision for voids tool, as I was mentioning earlier, we have split segments. This is a tool where we can actually say that we want to cut our pipes into 3 meter parts or 6 meter parts or whatever. And we can do that automatically. Clean up and deliver. This is a tool where we can remove all manufacturer specific data from a drawing. So if I have placed a lot of products that has factory or manufacturer names to it, we have certain product names and so on, we can automatically clean up that drawing and make it a generic drawing where it just says that we have a sprinkler head type 1, type 2, type 3, and so on. Also, we can use this tool to run a purge audit, and we can also use it to remove sheets, schedules, legends, views, and so on, links that we don't want to have in a drawing. Let's say we want to send this drawing to someone and we just want to have some parts of it. So, bill of materials. If you're familiar with Revit since earlier, then you know that you can make schedules inside of Revit, that you have these schedule quantities where you can see how many sprinkler heads I have of a certain sort. But it's hard to make a schedule where I can see the sprinkler pipes, the fittings, the pipe accessories, the sprinkler heads, and so on, all in one schedule. This bill of material, it's a static report. So if I create the report and then add some more sprinkler heads to the drawing or to the project, it will not update this report. I need to update it manually. But in one report, we can get all the materials that we have in the project as one report. IFC export. This is a tool for making an IFC export, and with this tool, we have something called a property set manager. So when we create the IFC file, we also can select what kind of properties we want to the different categories of objects in Revit. So if I make an IFC export for my sprinkler drawing, I can select that I want to have certain properties, certain parameters taken with me into the IFC file for sprinkler heads, and some other parameters for pipes and some other for pipe parts. So I will not get all properties, all parameters if I don't want them. I can select, and by that way I create a much smaller IFC file and with only the information that I really need. We have a tool called BCF Manager. It's BIM collaboration format. It's to create these BCF zip files. We can send them to someone and they can see, open a snapshot, and when they click on the snapshot, they will be taken to that place inside their Revit model. So it's a way of collaboration when you have some problems you want to share with some colleague and say that look at this point, we have some problem here, and you don't have to send your whole model, you can just exchange this file. Spreadsheet. This is a tool for handling parameters in Revit. So we have this tool and we have another one called Merge Parameters. The Merge Parameter tool, it's we keep that operation inside of Revit. So here we can say that, okay, I have 2 different parameters, or 3 or 5 or whatever, and say I want to merge these 5 into one parameter, for instance. And then I can do that. And this works with text parameters. The spreadsheet function lets us export into Excel. And then inside of Excel, we can use this data that we have exported to either extract information from another Excel file and compare and report back some different data, or we can take it into Excel and we can make some calculations to it. And after we are done in Excel, we just import it back into Revit and we get those updated parameter values into our model. Schematic symbol, it's a tool for creating schematics, just a drawing, simple schematics. Running index, just a numbering tool. I will not go into that more. Update parameters. When we draw something, we get some data. When we use MagiCAD's pipe drawing function, we are actually drawing Revit pipes, but we are also writing a lot of data to different parameters. When you draw pipe in Revit, you draw the offset height. You say you want to place this pipe on 2,500 millimeters above the floor. But then when you want to filter out something, the only parameter that you can get to is the one that's called invert elevation. And that's an absolute height from the inside of the bottom of the pipe. So it's kind of hard to use for filtering stuff. We have this own parameters to the pipes, for instance, that's called MagiCAD top elevation, bottom elevation, or installation elevation. And by using this MagiCAD pipe drawing tool, those parameters get their values automatically. MagiCAD will calculate the heights from this invert elevation and write it to the data. If we draw with regular Revit pipe, then we don't get any value to those parameters. But by using this update parameter tool, we can get those heights, those elevations to the parameters. This tool can actually do a lot more than just that. We can update inside of this data set. We can change the user code, for instance. We can change system codes. We can change different things, and then get this to change the data on the products that we have placed inside the model. So node numbering tool, we will look into that more later. Find and replace. When you draw with regular Revit and you place something, and then if you go into the properties and just replace it with something else, then sometimes you will lose data. It can be that you get, for instance, when you draw ventilation, you can lose the flow on the air terminals and so on. With this find and replace tool, you don't lose anything. And also, if you want to replace one sprinkler head with another one, both of them needs to be in the project as families, created families. But with this find and replace tool, we can take one sprinkler head that we have in the project, and we can replace it with another one that actually isn't in the project yet. And it will create that family and replace it. And then we have this sheet manager tool where we can create sheets. We create one sheet first as a template, place everything as we want it, and then when we have that as a template, we can then create 10 or hundreds of new sheets that are based on this template sheet. Symbol management, from that one we can create the 2D symbols that we want for our sprinkler heads, for instance. If we then look at the MagiCAD piping tab, then we have we have a tool called section box, 3D section box. We have a tool called selection filter, crossing, and here we have the multi-crossing. I will show those two. Angle to horizontal, standard connection. I mentioned these in the PowerPoint earlier. Then we have the tool for drawing the pipes, and we also have a tool for creating pipe series as a family in Revit. A tool for drawing floor heating, plugging the pipes, and from this button we can install the sprinkler heads or valves or pumps or what we want. Then we have a calculation control, and this one is not for sprinkler, it's for regular HVAC designing. But under here, under the calculation, we have the sprinkler sizing, sprinkler calculation, and sprinkler design area to place the sprinkler design areas in the drawing. We also have a tool, sprinkler connection, that helps us connect sprinkler heads to pipes. So let's start off by showing the install product button here. Press this one. What we have here is, compared to earlier version, is a completely new user interface. So from this part we can select, we can go into the ventilation, piping, or electrical, but in my case here I am just interested in the piping department. If I want to draw a sprinkler, I select the sprinkler device. If I want to draw a fire hydrant, I click on the fire hydrant. And in this case, there is no product selected to this data set. If I want to create or select one product, I can just right click and select new. And then I can go in here underneath the select button and say that, okay, in this case, I want to add a fire hydrant. And then we have some products inside here that we can choose from. So let's say I want to select this one. And then I can select a 2D symbol for this fire hose. So let's say I use this symbol. And I call it fire hydrant 1, for instance. Now I have this product and I can place it inside my drawing. Let's say I want to place a sprinkler device. I select one. First of all, when I want to select in this list, I can see all the sprinklers that I have added to my dataset. If I have added, say, 50 different sprinkler heads to my dataset, and I have placed in the model, I have placed only 4 or 5 different ones. Instead of scrolling through this long list that I get here, I can select, say that I want to show the ones that are placed in the project, and then I would see only those. So in this case, we can see that I have already placed 3 different kinds inside of my model, but in the dataset, I have 4 different types. I can also choose who I want, which way I want to sort the list. So I can sort it by user code, product code, or manufacturer. In this case, they are generic, but say that we have Victaulic or someone else, then we can select to sort it that way. I can also search in the free text. So if I know that there is some that is K115, then we'll see when I just write K1, then I get these 2 that are K115. So let's say I want to place this sprinkler then. I go to the OK. And now I have the sprinkler head. It's attached to my crosshair. If I go up here, I can select which system I want to place it on. I can select what area of coverage I should have. I can select what flow density I should have. So say I want to have 5 millimeters instead. Say I want to have 12 millimeters there, and maybe I want to have 500 millibars as a pressure level. Sprinkler head, this one is supposed to go downwards. It's a pendant one. So I can just go out here and I place it where I want to have it. And I can place more if I want to. And when I'm done, I can either press the apply button or the escape button. If I press the escape button once, then I get the opportunity of choosing a different product. So now I can select product and continue with another sprinkler head. And this one hasn't been placed in the drawing earlier. So now it takes a few moments to create that family. And after it has created that family, I can place that sprinkler head also. If I now go out from that command totally, we can see that this sprinkler head, it's placed on 2,700 millimeters as an offset. And it's a SP10K57. And if I look at this one, we can see that that's an ESFR K200 and it's placed on the same height. These measurements are the ones that MagiCAD are recalculating. So if I change something here, if I move the sprinkler head, these won't be updated. Then I have to go to this MagiCAD command tool and run this update parameters and run the update parameters for elevations. It's good to know. So you can't make height changes to that one. If you want to change the height on your sprinkler, you need to change it from the offset. So if I now want to place another sprinkler, if we right click on a sprinkler head and use Revit's function for create similar, we can then see that this sprinkler head goes to level to the offset of 0 in this case. If I use MagiCAD's function, so go back to piping and install product. If I'm now select just any sprinkler head, it doesn't matter which one I take. And then I go to this create similar and I click on this one. Then it will start to be using this one, but we can see that the offset is set to 2,700. So when I place this one and look at it, then it has gone to the floor offset of 2,700. Also in this install product, if I want to select a new sprinkler head, I just right click and select new. If I right click on top of an already existing sprinkler, it will be new or new copy of. If I say new copy of, then I will get the same 2D symbol and some preset data that is the same as this one had. If I select a new one, it will be completely empty, just the height. If I go to this select button and say that I want to select the sprinkler head, we have the cloud and we have a local database. So the local database, that is if I have downloaded product databases to my computer. Sorry, it's maybe I'm working offline, or maybe I have created my own product. Then I need to go to the local. But if I want to select something that is from Progman, then I'll go to the cloud. So browse and generic, and then we can see that we have different types of sprinkler heads. We have some CO2, we have some concealed ones, we have some ESFR, some conventionals, and we can scroll down this list, and it's a lot of sprinkler heads. We also have manufacturer-specific ones from Victaulic, and we can see that there are quite a lot. But sometimes still there is some sprinkler that we need that is missing, and we need to create it ourselves. But we can start off by just looking at how to add one. Maybe I don't know which one I would need. Then I can go to the search function and say that I want to have a sprinkler head that is maybe 20 millimeter in connection size. And I also want it to be a pendant. And then we run the search. None. Pendant. Maybe no. Let's see if we say that we want to have it. No, sorry, manufacturer. It was not that one. I was supposed to take the description. So, pendant, like this, search. And now it will find all the products that are possible to place as a pendant. And then we can select from them one. If I want to create a totally new sprinkler head, then I can use something that's called MagiCAD, and I have made it, I have opened it already. It's called MagiCAD. I will go into the generic product database that's installed together with the software. And this one looks like this, and I can go in under piping, and I can go under fire suppression and sprinkler device. Here I can see all the sprinkler heads that are already placed in this generic database. But let's say I want to create a totally new one. I press this create new, and I go and say, okay, I want to create this new one inside of this generic database. I want it to be, say, a conventional, and I just select this one. So now it will create that one, this with this size and everything, and then I can change this. So I will change the name for this one, call it test, like that, and I will make it as a pendant only, maybe. So I will take away this upright. So, okay, and I will save. If we now go through this list, if I just write an underscore and test, here we have this one. So if I click on the test here, I will get some more data for this specific sprinkler. And in this case, maybe I don't want it to be this high. Maybe I want it to be like 25 millimeters, and I want it to be 20 millimeter in connection size, and the base length maybe 50. So just make this weird looking sprinkler 50 for that one too. So, okay. And then I think I will go to this technical data. Okay. And here I can set the release temperature and what kind of response class it would be, standard, and maybe K factor 80. So, and here under advanced, I can also select if this, I said that I remove this upright. So in this case, I will only allow installation where the sprinkler head is down. And then I'm done with this. I click save. And if we go back into Revit and I say that, okay, I want to create a new sprinkler head or select a new sprinkler head. And I select it from the local database, this generic local database. I will now have underneath these others, I have my weird looking one. And I can select it to the project and I can call it test, for instance. And then I can select a 2D symbol if I want. And now I have it, so I can place it inside the project. So when I click OK, it will create a family for this one. And it will be possible for me to place it in the drawing. So that's basically how you install sprinklers to the project and how you select them from either the cloud-based product databases or from the local database when you have created a sprinkler head yourself. Draw pipe. If we draw pipe with regular Revit, then I take the pipe and I say what kind of material I want to use. In this case, fire protection wet, and we start with an offset of say 2,500 millimeters, and I will draw a pipe that is a 50 millimeter pipe. And then I want to make a height change. So say I want to go from this 2,500 to 2,000. And then I want to continue. In this case, Revit will manage to do this height change with two 90-degree bends. So that's why Revit will create these 90-degree bends. It will not ask me if I want to do this with 45-degree bends or something else. It will just create it. If I want to have this made with a sloping pipe, then I need to go inside of a section. So I have to make this section for this and go into that section view and just redraw this and say that, okay, I want to draw the pipe with a 45-degree angle down to the correct height and then connect it. And then go back and continue to draw from the floor plan. But if I use MagiCAD instead for this, if I take this MagiCAD piping command, click on that, and of course all the MagiCAD functions can be set with shortcuts, these keyboard shortcuts in Revit if you want. So fire protection wet, and we say we have a steel pipe, we say we want to draw it then at 2,500 and we wanted to use a 50 millimeter pipe. We also have the possibility of adding insulation as we draw if we want. We also have a reference button, so if I have drawn a pipe that is a certain pipe series and certain dimension, and then I draw something else, and then I want to draw this first type of pipe again, then I can just click this reference button and click on that pipe. And then I will inherit all those settings. But here I start to draw, and then I get this floating toolbar here. So if I click this angle to horizontal, then I will get this dialog. And in this dialog, I can say that, okay, I want to go. So if I now had let's say a cable tray or something else that I want to pass underneath, then I could just click I want to go bottom of and click on that cable tray. Or I can just write a value and say that, okay, I want to have my top part at 2,000, let's say 2,000. And I want to make this change with a 45-degree bend. If I want, I can use the free angles also. And then finally, I have this continue drawing. So when I have pressed OK, it will make those, and I'm still attached to the pipe, so I can still continue to draw. And if I now want, I can go back and say that, okay, I want to go center of this pipe. So I go up to the same height as this pipe. So 2,530 at the top with a 45-degree bend. Okay. And continue to draw. So what I have made here is actually I have made a passing. So if I was passing maybe a beam or a duct or something else, then I would be able to see it Okay, maybe not so good view there. Let's see. Where were I? I'm drawing this outside of the building, okay. That part, let's see if we just extract that. Here we have it. So, there you are. And just to show you, if I draw a cable tray, for instance, let's say we draw a cable ladder at 2,500, just like that. And then we turn on that category, just so. Okay, like that. So pipe, and we start to draw from this one again. Let's go closer to there. And then I just go to this angled horizontal and I say, okay, I want to go top of this ladder. And then it sends that, okay, in order to go over that, I need to go up to 2,585. But then they need to be able to put some cables onto that cable ladder also. So maybe I add an extra 200 millimeters and say, okay. And then I can just continue to draw, and I have passed that ladder. So it's a nice tool. I can also use this angled horizontal from a start. So I can press this pipe and say, okay, I want to go out from this pipe. I want to go out, and I want to go to a certain height. So let's say I want to go out and I want to go to 2,000. So I want to go down from 2,500 using a 30-degree slope or angle. I say okay. And then I will have to say what side. I will go to this side, and it starts and it goes out like that. The difference here is that if we are using a Revit pipe, if I start from this one, let's say we start from this one, I just inherit the heights and then I go to 2,000 and then I go out. Then Revit will make this with a 90-degree from scratch. We have no, the only way of getting the look that we have, let's see. I have difficulty speaking and acting at the same time here. Maybe it's because I'm a man. Go to view, like that. This is what we want to achieve. We want to go out and we want to have the T rotated inside the main pipe. And MagiCAD can do that. But if we draw with regular Revit, then we can see that if I just move this a bit and then we move this one like that, then we can see that Revit always starts, either it goes right straight out and then down, or it goes straight down and out. We can never get it to make this rotation inside the main pipe. In that case, we need to rotate the T branch first and then start to draw from that. So this is another time where MagiCAD helps us to draw from top view instead of needing to go into a section view or something like that. We can also see if we do it like this, if I take away that section like that, and I will do it like this. I will take away some parts here. Let's take away that one. I'll take away that one. We have this pipe. We have that pipe. Let's see if we take that away, that away, that away. Okay, so now I have this pipe. This is on 2,000 millimeters, and this one is on 2,500 millimeters. So if I want to connect these two, I have another tool in MagiCAD. It's called Standard Connection. So if I press this, the first one I click on is the one that will be kept at the same place, and the other one will be adjusted. So in this case, it can handle this by using a 90-degree bend, but it can also use it by taking two 60-degree bends and twist the bends to make the height change. So 60 and a 45, or 45 and a 60, or 30 and 90. If we do it like this, then we can take this one, just rotate it. That was not my intention. So same here, standard connection. We can take that one, we can take this one, and it will create the height difference with the bends. It will use the bends to make the height difference. Another thing we can do is that I can say that, okay, I want to take this one, and with the standard connection, I want to connect that end to here. And then it will connect to there. And also here I can select these different types. For ventilation parts, then we can select also if we want to have this as a T-branch or a tap. Obviously, we don't have that in the piping parts. But so if I create this like that, okay. And then we take this one, just copy it down here. And if I now say that, okay, I want to connect this pipe to this T-branch, then MagiCAD will handle that also. It will create an X branch from that T branch. And if I have a regular bend here, and then we have maybe we just do it like this. We mirror that one, draw axis. So these two parts, instead of first creating the T branches like this and then draw the pipe between these two, as we have to do with pure Revit, we can use the standard connection and say, okay, that band and that band, I want to connect those two, and it will create the T branches. Also, if I now have, let's say we do it like this, and we can copy this one, and we copy this one, and we take this one there. So, and then we take this pipe and we place it over those. These are now on 2500 and that are on 2500. So I think we have all the same height on everything. Yeah, it's colliding. We have the multi-crossing tool. So basically, with the crossing tool, I can make one height change. So I say that, okay, between this point and that point, I need to go top of those pipes, and I want to do that with a 45-degree bend. And then MagiCAD will create that height change like that. And if we look at it in a 3D view, we can see how it looks. The other way is that maybe I want to create my height change on these 4 pipes. Then I can go to the crossing, multi-crossing, and I say, okay, I want to make a change between this and that part. And I want to do that for this pipe and this pipe, this pipe also. And then I say, okay, finish. And it asks me about the height change, and I say, okay, I want to go top of that part, and I want to do it with a 30-degree bend, and okay. And now it will create for all of those. So that's about the piping. Let's go and see how it looks when we want to connect some sprinklers to the pipes. So we have this connection tool that's called sprinkler connection. I have a drawing here since earlier. I have placed like 6 sprinkler heads here. We can have a lot more, but I wanted to keep it inside of the house just for this, and then I will run the calculation using this also. So regular Revit use, we could create a new pipe by clicking on that sprinkler head and say that, okay, I want to go up to a certain height, and then I connect it to the main pipe out here, and then I use connect into to connect this pipe. But using the sprinkler connection tool, it's much more simple. We can select from 3 different kinds of connections. One is the inline connection, one is the antenna connection, and the third one is the grid. But let's start with the inline connection. So I just select all of my sprinkler heads that I want to have connected, and then I tell which pipe I want to connect this to. And then I can select if I want to do this by shortest path or if I want to do it by a constant. So I can say that I want to have this connection made with maybe 100 millimeter upright. Then it will create, we also get this preview here where we can see how it looks. So we can see that we get this uprise. Can also use this tool where we can change the alignment for the sprinkler. So in this case, if I write 100 millimeters into this one and update it, we can see how it will move this pipe to the side to connect to the sprinkler heads. And if we go here and look, we can see that we have gotten that side movement. So that's one part. The other one that we have, not sewer connection, sprinkler connection, is the antenna. And then I just select the antenna and I select all of these and say finish. And then I select where I want to have the pipe going out from the main pipe. And in this case, it will go out and it will go and connect those 4 on this side and those 2 on that side. And same way here, we can go and change these. And sometimes it will work, and sometimes we will get this pipe connection problem, for instance. And in this case, it gets confused about how to do it in these 2 parts. It needs to go up and at the same time, we don't have that kind of part. So we can still make this and it will not connect, and then we can go in manually and fix those small features. But the important part is that we get a message that tells us if something goes wrong. So that's the antenna. And then finally we have this, let's just make a copy of this pipe. This grid part where we say sprinkler connection, and we say that we want to connect these sprinklers. Sorry, I forgot to select the grid like that. I take those 6 sprinkler heads and I say, okay, finish. And then I select, I want to connect them to this pipe and that pipe. And same here then. Now with this 100 millimeter constant movement, it will not work. But if I go to the shortest path, it will manage to do this. So let's see if we look into this. We have them connected straight over here like that. And I think actually if we go and look, we take and select that solution, and then we select this one with 100 millimeters. And we just update that. No. But if we run that one, Okay, strange. I was quite sure that it works. Maybe I have something that's weird in my model here. So I don't know why it didn't work as it should. But anyway, as you see, we get this warning when it doesn't work. So we can just select OK, and it will create that, and then we can go in manually and edit or alter. But let's say now I want to connect these, and I want to connect them to with this inline connection like that. Finish, and we select this pipe to connect it to, and just OK. So, and then I'm done. So I will remove that pipe also. So we have connected those now. To place a sprinkler design area, you use this function. It's called sprinkler design area. I have already placed one, so we have it here. I will try to highlight it. Select all instances visible in view. It wasn't so. Maybe you see it better now. It's a green area here. And if I select one of these, I can see the area of that sprinkler design area. It's 54 square meters. So anyway, these are the rooms or the sprinklers that I want to create the calculation for. I will also run a sizing. And the sizing, it works like this. If we go into the data set first and just look at the sprinkler sizing method. In this case, there are two different calculations. We have the low hazard, and we can see that if I have one sprinkler, it will create a 25 millimeter pipe. If I have, when I get 3 sprinklers, it will be a 32 millimeter, and if I have 5 sprinklers attached to it, it will be a 40, and so on. If we want to add something, we just click the add, and we just say how many sprinklers and what size we need in that case. So we can easily create our own sprinkler sizing methods if we want. So I will back out from that, and I will go to the calculation and sprinkler sizing. Here I just select the calculation sizing method I want to use, and then I just click on something that's part of the system I want to calculate. So in this case, it will go through my drawing and say that, okay, these are the changes I will make. So if I'm satisfied with that, I can just click OK, update to model. And we get the sizes to the pipes that as we have said, that we wanted to have. When we want to run the calculation for sprinklers, then we make the same. We go to the calculation button, and we just click this sprinkler calculation, and then we press something that's part of the system that we want to calculate. And here we'll get all the design areas that we have inside of the drawing. In this case, I only have one design area. We also will be able to select which kind of calculation standard we want to be using. We can select if we want to calculate using Hayes and Williams or Dorsey Weisbach. We can also select if we want to calculate based on minimum pressure, pump pressure, or feed point pressure. So what this means is actually that minimum pressure, then we just calculate and see, okay, this is how much pressure and this is how much flow I need to have to get water from the worst case scenario sprinkler. If I check this one, balancing to pump pressure, then if I have placed a pump in my model, as I have up here, it will calculate using the flow and pressure from that pump into the system. And if I have this balancing to feed point pressure, then I can say that, okay, I have so much pressure and so much flow that comes into my system. What will the end result be for the sprinkler heads? So then I just give here some pressure in that case. We also have these welded pipes start from size and warning limit of high velocity, so I can get some help to know if I'm way off or not. But if I now press OK, balancing the pump pressure, then hopefully we will get the result like this. So in this case now we have calculated this, and we can see that we will need 751 millibars, and we will also need 416 liters per minute approximately. We get some more information here about average sprinkler height and flow density and weakest for sprinklers and so on. And we can see which sprinkler are the weakest. You can see that our feed point is number 27, node number 27, and our weakest point sprinkler is number 26 in this case. I can also see the results for just the sprinklers, see how they are compared to each other. I can see the system results, where I can see what parts has been used, if I have any warnings for my system, and the equivalent length that has been used. Underneath the equivalent length value, there we can see all the different equivalent pipe lengths that has been used in the calculation, what size and what value. And then we have the pump diagram that we also get. And all of this can be printed to a PDF or copied to clipboard and pasted into Excel, for instance. So if I make this print and we say that we print it as a cute PDF writer, skriv ut. And then we print it maybe to my desktop just like this. Spara, save. And then I run this, okay, update to model, and it will enter those values into the pipes wherever we have them. If I now go out and I see my MagiCAD HVAC file here, then we can see the report, and we can see the different parts of it and the sprinkler pump diagram also. These columns, we can, when we are in the report, we can move these borders so we get everything to be visible. And then when we print it, it will look like it do in the report. So go back to Revit. After we have made the calculations, we want to present the node numbers inside of the drawing. So then we can just go to the MagiCAD Common tab and click on this Show Node Numbers. And we want to do it for maybe system, all, or network. So if I take network and say OK, and I click on the pipe, and everything that's connected to that pipe, it will go and present those node numbers. So everything that has gotten water through it will have a node number, and we can see we have the open end there also. One more thing that I wanted to show. Let's see, we will turn off the cable trays again. It's a bit annoying to see them like this. Another thing, when you place products, I showed you earlier how to place a sprinkler head, but we might want to place a stop valve or something else, and then we have the possibility when we say that we want to place a stop valve, and say I want to take this stop valve, I can select what size I want to place, like this, and say OK, and then it will give me some options. So in this case, I can use the selected size, and then it will place a 50 millimeter valve, since that's the size I chose. And that will be placed regardless of what the pipe size is. Or I can go to continuous, and continuous mode, it will mean that when I click on a pipe, it will read that pipe's diameter, and it will create the family size for that valve according to that pipe's size. So if we click on this pipe that's a 80 millimeter pipe, then we will get the corresponding valve for that. And then regardless of the size of the next pipe I click on, it will be the same size as the first one. Auto size, then it will look at this pipe and say, okay, this is an 80, so I would create a valve that's 80 millimeters. And then I click on something that's 100 millimeters and create a 100 millimeter valve. But the first click, it will read the pipe size and it will create the family. And then I need to click once more to place it exactly where I want to have it, like this. If I select the smart mode instead, then it will read the size of the pipe and it will place it on that part. In this case, we can see that when I clicked on this pipe, it's not one pipe. There is actually 3 different pipes on top of each other. So we have some tap water pipes and we also have this steel pipe. So it will list in order those different pipes. This works also for vertical pipes. So I will remove this again. If I take this install product and the stop valve, okay. And I use this smart function. If I now go to this vertical pipe, it will give me an option to place this valve at a certain height. So it will sense that the pipe is between 8,010 millimeters and down to 4,589 millimeters. So it suggests that I place it in the middle, but maybe I want to place this at 7,500. And okay, and that will place it there. And if I then go and say, okay, I want to place another one, then it will show me that I have 2 parts. One that is between 7,477 and down to 4,500, and one from 7 and 5 and up to 8. So if I take this one now and say, okay, I will get the same dialog again and can place it on a different height. So in this way, I can place valves on top of each other in a vertical pipe without the need of going into the section view. Also, the calculations, when I have a valve that is added to the system, it will look and read the table values for this pipe part. But I can also give it an equivalent pipe length of my own. So if I go into this product and say that for an 80 millimeter pipe, I want to have a certain equivalent length. And then I just write whatever I want to have there. So let's say 5 meters. And then when the calculation is run, it will see if there is a value, it will calculate, use that value. And if there aren't a value for it, if it's 0, then it will use the value from the table. So next thing, when we use the sprinklers, maybe I want to create my own 2D symbols. When I select the sprinkler to the project, I get the possibility of selecting, let's go into this dataset properties. I can select from a lot of different 2D symbols here. And I can select from different market areas. I can also select, I could choose like a flow damper symbol or a tank symbol or something else and say that this is going to be my 2D symbol. So I'm not constrained to only use symbols that are in our database as a sprinkler symbol. I can use from any category if I want to. But let's say I want to create my own 2D symbol, something that is not available as of now. Then I just go cancel here and cancel. And I select to draw, let's see, system, component, model in place. I will model something that is a sprinkler symbol. So I just select model line and I want to make this as a circle. I want it to be like 200 millimeters, like this, and say I want to create another one that is 80 millimeters, and then I want to have one more that is like that. And then I want to have maybe some lines from there to there and there to there. So, okay, and now I'm happy. This is my sprinkler symbol. This is how it's gonna look. So I just say finish, I'm done. Then I go into the MagiCAD Common tab and I select the symbol management and create user symbol. Then I just click on this symbol and say that, okay, it's going to be a product symbol. It's going to be a sprinkler device and I want to call it, yeah, let's call it test. Or let's call it UB test, like that. Okay. Now I can just remove this. I have created it now as a 2D symbol into the data set that we have. I go back to MagiCAD and install product, and I want to add this to a sprinkler now. So let's say I go and make a new copy of this one, and I want to have the sprinkler symbol should be my UB test. As long as I have the user checked, this will appear. Call it test 2. Let's call it test 2. And OK. So we have it here, and I say OK, I want to place it. And it now creates the family for both that 2D symbol and the family for the sprinkler. And if we look at this with the 2D symbol, you can see that this is our new 2D symbol, easily created. One more thing. Provision for voids. When we run the provision for voids tool, we have a manual and an automatic option. So if I select the automatic option, then I can say I want to run this in this view, or I can say I want to run it on several different levels. But let's say I want to run it only in this view. And I press OK, and it will tell me how many provision it will create. So in this case, it will create 33 provisions. And we can see here now that we have gotten these provision for voids here. Those can be texted, so I can say what height they are on. And also, if I send this drawing or send these provisions to the architect, to the construction people, they can use our void tool. If I go to add-ins, I have this void tool. So they just have their architectural model and they link in our model, or link in the model containing these provision for voids. And then when they run this void tool, it will sense all those voids, and they can create by just selecting the ones they want to create. And when they are in their model, they can just click this create void, and it will make that cutout physically into that wall. And then when we take it back into Revit here, we can see that when we make collision control, for instance, it will not find any collisions. I see we had some time, so maybe I show you the function. In this case, what's deciding how big these provision for voids should be then? Well, inside the data set, we have a setting for it. So it's called the provision for voids, and when we click on it, we can see that we can set different offsets depending on what discipline we are running. So for piping, we can say around the circular object, we want to have an added 50 millimeters of space. And if we have two pipes that are close together, we can say that we want it to create one hole for both of them. Or if they are further apart, it will create separately. We can also say that if the holes are pretty small, let's say that we can use a regular drill to make those holes, we can ignore them and say that it will not make any cutouts for those. And we also have some rounding steps and rounding up and down limits, so we don't get some odd sizes of the holes for this. But let's say I have my model here. I just save it like this. And we can run an interference check just to see that we have some collisions as it is now. I will run it through between the architectural model and my project, and I will run it through the pipes and walls. Okay. And it will now find quite many collisions. And if we just open this, if we zoom out a bit, we see in this case, let's go up here. Let's see. Show. Okay. Let's see them. We have something. Well, I'm not quite. I think it's this one. No, it's not. Okay, it's a wall between two floors. We have that one. It should actually find the collisions between those because I haven't made the cutout yet. So let's figure it out. Why doesn't it show these? Usually we get this orange. Okay, it was quite many. There we had something. Okay. Sorry, because now it finds the in this model there are quite many pipes. It's pipes from it's just not, they are not just lighten up here. We have, okay, let's make it like this then. Interference check, run interference check. How should I do this in a good way? I reckon that we have some filter or something that is turning off what's not sprinkler, but there are still pipes in this view, so it will find them. Okay, I will. I just decide I won't show that. It takes too long time to change the pipe types and then run this. Since we have these provision for voids, what we do then is just that we save this drawing and we send it to the structural engineers. They link in our drawing to their drawing and they run this void tool and then they say, okay, I want to create the cutouts. After that, they save the drawing and send it back to us. And then our provision for voids here are no longer a provision. They will be the actual cutouts in that model. So where we had collisions earlier, we won't have them anymore because the cutout is made. And they can also say that, okay, I won't make a cutout for this one because it can't be here. We need to move it 500 millimeters to the side. So they can write and create a report file from this void tool. We can see inside of the tool that we have this save report. And then if they send us that report, we can open the report and see why they didn't make the cutout. What do we need to change in order to make this work? So that's those parts. Then I can make one more thing, maybe show the sheet manager tool. Let's say that in my case here now, I have this floor 1, and when I'm on this floor, I want to make some sheets now to be able to plot this. This house is too big to be placed on one sheet. we can see if we go in here, and if I drag my floor 1 into this, you can see that there is no way I'm gonna be able to fit my whole house. Yeah, almost. This is a big drawing, it's an A0, I guess. Yeah, but in any case, if I want to make these sheets, I can place them. Let's say I do it like this. We duplicate this view as a dependent, and I make another dependent view here, just 2 of them. So I say that this is my floor dependent, let's call it part 1. Like that. And then we have this one, we call it part 2. So, and then we just, in these views, we just crop them a bit. We can use crop region, or we can use the section box if we want, or scope box I meant. But let's just do it like this. So, and then we take the other part, and I just take this one and say, okay, okay. Okay, I just make 2 parts, and I want to have these on different floors. So let's say we do it like that, and then we say apply dependent views, and we take it to floor 2 also, like that. Okay, so now I have the same, I see the same things on the different floors here. And I will go to my sheet now. I remove this that I placed first, and I say, okay, I want to place this from the parking. I want to place this one and set it there. And I want to use this as a template to create 5 more drawings. So I just use the sheet manager then and say that I want to use my V54-101 as my first floor. And then I get this one, and I can see I have the sheet number 54-101 and 1 first floor. And I see also what kind of view that are dragged into that sheet. And then I can make my next one, 102, and I can say, okay, in this case, I want to have that one, the dependent 2. And then I can continue this and say, okay, if I need to change this maybe to 2054/201, and then I will need to say that this is second floor, like that. And then we say we use the one that is second floor dependent it. And now we take the second floor dependent 2 and continue like this. And then I press OK when I'm done. And then it will create the following drawings there, and we have the second floor drawings here. So now I have all of those. So this one looks like that. This one looks like this, like this. So we can use this tool, the sheet manager, to easily create multiple sheets with the same, what should you say, where everything is placed in the kind of the same place during all it. If we don't have this sheet manager, we need to make these by ourselves. New sheet, select what kind of sheet we should have, drag a view into that, and then place it. And then when we're done, right click, select to choose the next one, and so on. And in this case, we had quite a few things in the drawing. Maybe you have some ruler, and maybe you have some explanation text, and maybe you have some detail view or something that's also placed in your drawing. When you use the sheet manager, it's quite fast to use it. Another thing I was thinking about is, let's go back to this. if we mark a sprinkler head, just select these and filter out the sprinkler. Then we can see that I can now select from these different types. These are sprinkler heads that I have placed inside my project. If I would like to have a sprinkler head that's not placed already inside my project, if I'm running pure Revit, I need to first create that family, and then I can select it from this list. But if I'm using MagiCAD, I can go to this Find and Replace button, and I can say that all of my sprinklers of this same type as this one, I want to select them to be something else that is in my dataset. And it could be a different size, or it could be something else. So in this case, if I want to replace this SP15K115 to an ESFR sprinkler, for instance, I just click the Apply button, and the replacement is complete. Usually we get some 3D view in that part. Show like this, so we can see where it is and so on. But if I'm satisfied with that, we can go out, and if I now click on that sprinkler, we can see that it's an ESFR. So all of my sprinkler heads of the same type as that one would be changed for an ESFR then. So, well, we also have this tool that's called 3D Section Box. So if I want to look closer to the things that I have inside of, for instance, this space, I can just click on that space and say, okay, I want to create a section box. I want to close all other views, and I want to put this floor plan and the 3D section box next to each other to be able to compare them. And I want to create this in maybe in this one, 3D SD floor. And I say, okay. And if we now look at this, we can see from side that this is the sprinkler parts inside of that room. So a fast way of getting a 3D box just around the parts I'm interested in. Of course, I can alter this afterwards, so I can change and drag with these handles to see more or less. So, okay, I think that's about it. I have no more to show actually from this. I will look in and see. So how is it now? Is it so that someone has any questions? There is a question field where you can write some questions. It's inside of this GoToWebinar tool. If not, I will have to say thank you very much for your interest. But I will wait a few minutes and see if someone has any questions.